Okay, you guys, so in this section 10.1, the parabola and the circle. So we've already discussed parabolas a little bit. We're going to kind of review some topics in there, and then we're also going to talk about horizontal parabolas in relation to vertical parabolas. Okay, so first thing, part A, we're going to talk about is graphing parabolas of the form x equals a times y minus k squared plus h, and y equals a times x minus h squared plus k. So notice this is the one right here, the bottom one that we're used to. This is going to be the new one, okay? You notice that the y term is right here and it is being squared, okay? So that's what's going to make it different. This is the horizontal and this is the vertical. Okay, let me change the font of my pen, okay? So the next thing we're going to talk about is graphing circles of the form x minus h squared plus y minus k squared equals r squared. This is kind of what I refer to as standard form for a circle. And then we're going to find the center and the radius of a circle given its equation. And we're going to write an equation for a circle given its center and radius. Okay, so the beginning will be about parabolas and the end of this section will be about circles. Okay, and they're not too bad. So this brings us to the idea of conic sections. Our names, so each conic section is the intersection of a right circular cone and a plane. So if you take a cone and you cut it straight in half by a plane, you will create a circle. If you take a cone and you cut it at an angle like this with a plane, you will create an ellipse. If you cut a cone and you cut it at a slight angle like this, you will create a parabola. And if you cut two cones stacked on top of each other with a plane like this, you'll create a hyperbola. Okay, so that's why they get their name, the conic sections. So a circle, an ellipse, a parabola, and a hyperbola are all named conic sections because they're sections of a cone. Okay. The parabola. So just as y equals a times x minus h squared plus k is the equation of a parabola that opens upward or downward, x equals a times the quantity y minus k squared plus h is the equation of a parabola that opens to the right or to the left. Okay, so once again, this is what I call a vertical parabola, meaning you get a parabola like this, or you get a parabola like that. Now this, when the y is being squared, you are going to get something called what I call a horizontal parabola. And you'll get a parabola that faces like that, or you'll get a parabola that faces that way. Okay, so that's the main difference. So you already know how to do vertical parabolas. Now we're just going to spend a little time on horizontal parabolas. Okay, so here you guys see they have a nice little set of drawings for a vertical parabola, and here they have a nice little set of drawings for our horizontal. And this is vertical. Okay. So let's take a look at one, and we're going to look at a number chart. I'm sorry, a table of values. Okay. So we have graph x equals 4y squared. So instantly you guys should know something's wrong right here. The y is being squared instead of the x. Remember, we're used to seeing this, y equals 4x squared. So that's a parabola we're used to seeing. So we're no longer working with that in this particular problem. Now we're working with x equals 4y squared. Now there's multiple ways you can build a table for this. I think in the book here, they choose to still pick x values and see what the y values would become. You could also pick y values and see what the x values would become as well. Either way would work. So here we notice in this problem, they're telling us that our a is worth 4, our h is worth 0, and our k is worth 0. Okay, and that's because if we go back up to this equation right here, this one right here, a times y minus k. So if we do x equals a times y minus k squared plus h, right? So if we go back to that equation, we see that right here, there is no plus h, right? So it's technically, let me do it in red, it's technically plus 0. And then we also see that this is 4 times y minus 0 squared plus 0. So this would be basically how you could write it, okay? So let's take a look at this. Let's build a little table. So basically what I'm going to do is I'm going to show you guys how they use these to get these. Okay. So the first thing they did is they said, well, what if x equals 4? Okay. So they said 4 equals 4y squared. And we divide both sides by 4. We divide both sides by 4. So we get 1 is equal to y squared. Now we know that if we're trying to solve for y squared, we have to square root both sides, but then we have to include plus or minus. So we now have plus or minus 1 is equal to y, okay? And that is how they got this value and this value. So instantly you should notice something right away. Plugging in one x value gives you two different y values. We automatically know that means it will not pass the vertical line test. So that means this is not a function. That's why we don't spend a lot of time on these problems in the beginning of the semester, because a lot of algebra is about dealing with functions and working with functions. And if you're dealing with a horizontal parabola or a sideways parabola, you are no longer working with functions. Okay, so some of the conic sections, actually all 4 of the conic sections could be non-functions. Okay, so that's how they got the plus or minus 1. Now let's do the other one. They say, let's let x equal 2. Right, so they come over here and they let x equal 2. So then you say 2 equals 4y squared. They divided both sides by 4, just like before. So we now have 1/2 is equal to y squared. And just like before, we square root both sides and we do a plus or minus. So we end up with y equals plus or minus, or I'll do it the way I had it on the other side. Plus or minus the square root of 1/2 equals y, which is approximately plus or minus 0.70. I have it on my calculator real quick. 707. So that's how they got 0.71 right here and negative 0.71 here. Okay, so that's how they chose to do it. Now you could choose, instead of doing that, you could choose, okay, so we have x equals 4y squared. Couldn't you just pick your y's first? You could pick y equals 0, y equals 1, and you could pick y equals -1 if you want. You could also pick y equals, let's see here. Let's say 2 and -2. Okay, so if I plug in 0, right? If I plug in y equals 0, then x equals 0. Okay, so we could do that. If I plug in, let's say right here, let's do y equals 0, y equals 1, y equals 2. Let's do it in the order I have it written. Sorry about that. Y equals -1, y equals 2, and y equals -2. Okay, so if I plug 1 in here into this equation, I get y equals 1, so x equals 4. If I plug -1 in there, I still get x equals 4. Okay, if I plug positive 2 in there, let's see, we get 4, we get 16. X equals 16. And if I plug in -2 into there, that would be -2 squared would be 4. 4 times 4 is 16. So I would get 4, 4, 16, 16. So you could also do it that way. I think they just wanted to kind of stick to the you always plug in for X situation. But as you can see, it's not quite as nice as you would like. We now have this decimal that we kind of have to approximate. So it's really difficult to write approximations like that. That's why they have these two values right here. Okay, but yes, this is our parabola now, and it is now a horizontal parabola. We see that the axis of symmetry is different than before. The axis of symmetry is cutting right down the middle like this. And the axis of symmetry is now y equals 0. Notice they said y equals 0, not x equals 0, because x equals 0 would be this line right here. And that is definitely not the axis of symmetry. It opens to the right. Now, how do we know it opens to the right? Well, because a is a positive number. So a lot of what you've learned previously still works, or still applies. So if a is greater than 0, opens right, opens to the right. And if a is less than 0, opens to the left. And again, think about it. Negative numbers are on the left side, positive numbers are on the right side. So depending on if a is positive or negative, and just like before, if the absolute value of a is smaller than 1, meaning it's a fraction, like 3/4 or 1/2, it will become a wider fraction or a wider parabola. And if the absolute value of a is bigger than 1, like let's say it's a 2, 3, 4, or 5, then you're obviously going to have a more narrow parabola or a skinnier parabola. So in this case, a equals 4. So this is a skinnier parabola. If it was 1/4, it would be something like this, right? Okay. So just kind of keep in mind that everything you've already learned about parabolas still applies, but it's just kind of, I don't want to say backwards, but you got to shift your thinking a little bit because now you're working with the axis of symmetry being the y-axis, being y values, okay? Not the y-axis, but y values. Okay, so let's take a look at this one. Graph y minus 4 squared plus 1. So let's see how they came up with this parabola. Okay, so I'm going to do it in red. So I'm not even going to worry about the number chart. I'm just going to try to think about how it worked when I did my transformations before. So if this were y equals x minus 4 squared plus 1, this would be a vertical parabola, right? This would be the up and down one. So a vertical parabola. Okay, so then my thinking would be, well, then this would have a vertex and it would be positive 4, 1, right? So we would draw our little shape and we would go 1, 2, 3, 4, and then up 1. Okay, and then we would draw it upward. Oops. It would be kind of the normal shape parabola because a is equal to 1. And we would have a parabola like that with an axis of symmetry going right down the middle. Okay, now here's the thing. Because we have a horizontal parabola, and how do I know? The y is the value being squared. So because the y is the value being squared, or I should say the variable being squared, we know that we're working with a horizontal parabola in this case. Okay, so I got to clarify. If only the y is being squared. If the x and the y is being squared, then you could have a circle, a hyperbola, or a ellipse. Okay, so when only one of the variables is being squared, you're probably working with a horizontal parabola or a vertical parabola. So let's just take a look. So now what if I switch it like they have? So x, let me do it in blue because that's the actual one we're working with here. Okay. So we have x equals y minus 4 squared plus 1. So this is completely different now, right? So now if this was the vertex of the other one, that's because the 4 was associated with the x. Now we have to say, well, this time the vertex, the 4 is associated with the y. So that means that the 4 goes here and the 1 goes here. So this is now my y coordinate and this is now my x coordinate. But in this problem, this was my x coordinate and this was my y coordinate of the center. Okay, so it's kind of like opposite day, right? It's like it's backwards from how you want to do it. You still understand where it all comes from. You still know how to transform it. But now when we do it, we're going to go over 1 and up 4. 1, 2, 3, 4. And we put this. Now we know it's right facing because a equals 1 and it's positive. So we know it's going to be something like this. And again, we don't know exactly what it looks like, but it's some shift or some right facing parabola and it has a equal to 1. So it's the normal size. If we come over here and look, that's the exact same as us. Okay. And again, if you used a table of values like they did, you would get more values. So there's two ways to look at it. You can still build your table of values, right? Which is very good. That's like the old fashioned way to do it. Or you could try to use the transformations that we learned for parabolas, but you have to change your thinking. Okay, you have to reassociate what's inside the squared for your y coordinate now, and you have to reassociate what's on the outside as now your x. That is completely a flip of what happened here and here, okay, in your old vertical parabolas. All right, so let's move on. So now what if they ask us to graph negative x squared minus 4x plus 12? So we're going to go the, the old fashioned, or not the old fashioned way. We're going to go with the completing the square method. Now notice this is a x squared. So this means that this will be a vertical parabola, okay? So I'm going to do negative b over 2a. So you could either complete the square or you could use vertex form, okay, to find the vertex. So I'm going to use negative b over 2a just because it's easier. So we have, in this particular problem, negative b, so this would be negative 4, which become positive 4, and then over 2 times a, but a is negative 1. So we get 4 over negative 2, which is negative 2. Okay, so now we have negative 2. All right, now if we want to find the y coordinate, and this is the x coordinate, now if we want to find the y coordinate, we just do f of negative 2 or y of negative 2, and this would become negative times negative 2 squared minus 4 times negative 2 plus 12. So this would be negative 4 plus 8 plus 12, and that would become what, 16? We get 16. So we have the vertex is the point negative 2 comma 16. And then if we go over here, we see the graph of it. The axis of symmetry is negative 2. And we see that it is a vertical parabola and it's downward facing because since a equals negative 1, this is less than 0. So it is a downward facing. Or some people, or you could even call it, probably the more technical term is to say concave down. Okay, we know the axis of symmetry is always the x coordinate of the vertex with a vertical parabola. So we see this line going right through the middle here. That is our axis of symmetry. And it's kind of everything else we already know how to do. They plotted some points. You may be asked in the homework to do a table of values. So you might be asked to plot some points, but you kind of just know how to do that already. I was just trying to show you using the vertex formula. This is a little bit easier to me. Completing the square is always your last choice unless you specifically are asked to do it. It's a little bit harder than the vertex formula. Okay, so let's move on to circles. A circle is a set of all points in a plane that are the same distance from a fixed point called the center. The distance is called the radius. Okay, let me see here. I also wanted to, oh, sorry about that. I was clicking on something on my other screen. So circle is a set of all points in a plane that are the same distance from a fixed point called the center. This distance is called the radius. The graph of x minus h squared plus y minus k squared equals r squared is a circle with center h comma k and a radius of r. So this is what I call standard form for a circle. Okay, so that's kind of what you want circles to be in. And if they're not in that form, usually you want to force them to be in that form by completing the square. That way you can find the center very easily, okay? So let's say we have a problem x squared plus y squared. So they rewrote this for you, showing you that this actually is x minus 0 squared plus y minus 0 squared equals 3 squared. Remember, whatever the radius is, it has to be able to be written as something squared. So if you say that on the right-hand side it's 9, 9 really means 3 squared. So we see that the center they took from here and here, and that's how they got the center. And the radius is whatever this is square rooted. So we get 3, okay? So it's pretty straightforward with circles. And then all you do to graph is you take the center and you walk up 1, 2, 3, put a point, walk to the right, 1, 2, 3, put a point, walk down 1, 2, 3, put a point, walk to the left, 1, 2, 3, put a point, and you connect the dots. And that's how they create, ooh, I can't draw. You guys get the idea though, right? That's how they created a circle. All right, so let's move on. All right, so here's an example. Now, they want you to use the form to very quickly find the center. So you see here, x minus 3 squared. So that's how they got the 3 right here. Then you have y squared with nothing next to it. So that means that it's 0. So that's how they got the 0 here. Once again, 9 is what they say is on the right-hand side of the equal sign. So that's another way of 3 squared is another way of saying 9. So we get a radius of 3. So we have our center of 3 comma 0, and we have a radius of 3. So this time we walk over 1, 2, 3, and we put our center. And now from here, we walk up 1, 2, 3, put a point to the right, 1, 2, 3, put a point down, 1, 2, 3, put a point to the left, 1, 2, 3, put a point. And then once again, we draw our circle best we can. All right, so that's how you can create a circle if it's in this form. So this is the nicest form ever because you can tell just by looking at it what your center is, and you can also get the radius. So this form works very well for finding the center and radius quickly. Okay, we, I would compare this for circles. I would compare this to y equals mx plus b for lines. Y equals mx plus b, the moment you see y equals mx plus b, you know the slope and you know the y-intercept. You know information so quickly just from looking at it. Standard form for a circle tells you the center and the radius very quickly just by looking at it. Okay, now what happens if it's not in the right form? Okay, so if it's not in the right form, we're in trouble a little bit. So what we have to do is we have to complete the square. Notice this is not in vertex form. So we're going to regroup the terms like it says right here. Okay, so I'm going to write it as x squared minus 2x plus, and then I'm going to leave a blank, just like back in when I taught you guys completing the square. Then I'm also going to have plus y squared plus 6y plus blank, and I'm going to set that equal to 6. So what's going to go in those blanks is the completing of the square of this and the completing of the square of this. Okay, so let's do this in red. So over here on the side, remember you have to take half of -2. So -2 divided by 2 squared. So this would be 1, right? So this becomes plus 1. But I just added 1 to the left-hand side, so I have to plus 1 on the right-hand side of the equation. Okay, now here, remember, we're going to focus on this 6. What's half of 6? So 6 cut in half and then squared. Well, that would be 3 squared is 9. So we're going to put a plus 9 right here, but I also now have to put a plus 9 over here. So now let's do a factor on this. This would be x minus 1 squared. I'll write it out for you guys and then we'll fix it just so I don't skip too many steps. So this will be x minus 1 times x minus 1 if I factor it, plus y plus 3 times y plus 3. And remember, that's the point of completing the square, is it should be perfect. Okay, so now this becomes x minus 1 quantity squared plus y plus 3 quantity squared equals 16. So a couple of things significant. Number one, there's a plus sign in the middle. Okay, and number 2 is we now have this perfect form right here. Now the plus sign in the middle signifies that this is either a circle or an ellipse. If it had a minus sign, that would signify that it's a hyperbola. Okay, or you're probably working with a parabola, hyperbola. I'm sorry. So for this one, we know this is a circle with a radius of r equals 4, because 16 is really 4 squared, right? And it has a center of 1 comma -3. Okay, so if I come down here and look, let's see here. They say the center is 1 comma -3 and the radius is 4. Okay, so and here we go. Here's their 1 -3 and then a radius of 4. So they did everything we did, but this is just a nicer drawing than I can do. But once again, I'll just walk you through it. I went over 1, down 1, 2, 3, and that's my new center. Now from there, I do the radius of 4. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4. And then once again, we draw our circle best we can. I'm not really good at it, but you get the idea. Okay, so it works. So completing the square gives us the standard form of a circle. This is what we want. We want it to look like this, because if it's in this form, we can very quickly find the center and the radius. Okay, so now let's go the other way. It says write an equation of a circle with a center of -7, 6 and a radius of 2. Okay, so that means that we have to identify H, K, and R. All right, so let's see here. Let me just double check. So now we see that H is -7, right? This is my H comma K. So H is negative, oops, those commas are in the wrong spot. -7, and my K is 6, and my R is 4. Because we're, oops, yes, because, oops, radius of 2. Now, here's the thing. When I go to plug all this in, let's see what we get. We get X minus a -7 squared plus Y minus 6 squared equals 2 squared. So this would be X plus 7 squared plus Y minus 6 squared equals 4. Okay, so all I did was I took these values and I plugged them into the standard form of a circle. Okay, so it's really not terrible. The hardest part is if they give you a circle that is not in the right form. So if this is not in standard form, that's when you have to complete the square and it gets a little bit harder. And again, there's a lot more you can work with on circles, hyperbolas, and ellipse. But this is just kind of like an intro. So you've seen it before and you kind of understand how standard form can be used. So you'll work with some homework problems like this and it shouldn't be too crazy. Okay, you guys, that's going to do it for this video. If you need any help, please, come see me during my meetings. Thanks for watching.